This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Hey, my name is Kostiantyn Tsymbal. I work at Google and I have a lot of experience in different companies, so I would try to base this speech on my experience. I was working in small companies like, service companies, and it was middle companies as Fiverr. And now it's Google, so I know from experience how is it to work on backend in different setups. So yeah, disclaimer, no AI in this speech. So thank you for AI, but yeah, not for my speech. So let's speak about API protocols. How many of you are backend engineers or just know how backend looks like? Okay, fine. So I'll just give you a brief introduction of what we do on backend, mostly. So when we started doing backend, there was REST API. It's just most used API protocol. You just have requests, you have a few methods, and you can just communicate with your server. And so it's used by 86% of users, so it's a pretty huge amount. Even now it's decreasing. So new protocols became more and more popular, yet it's huge number. And what frameworks do you use on backend? I'll just keep it short. So we have Express. It's something old, most. It's based on JavaScript, so more or less no types, and just mature framework. Then there was Koa. Koa was a way from Express engineers to make it better. They tried to make it better, and yet it's super popular, 4.7 million of downloads. But from my perspective, I don't see it used in big organizations. What goes next is Fastify. I remember we were using Fastify in more or less small organization, let's say. And the good about Fastify is that it's more or less good integrated in the ecosystem of backends. It has a lot of native plugins, so like more or less everything should be done natively, kind of telemetry, documentation also, and like 90 plugins, and they're super easy to do. So if you want to, just distribute packages, we can do it via plugins, and it's super easy. And then goes Nest.js. Nest.js, it's 5 million downloads. It's a very modern framework for backend, let's say. And it's similar to Java. So I believe if you have experience with Spring Boot, you would probably go and do it on Nest.js server. It has huge infrastructure around. So everything is just created from engineers from Nest. Don't need to care. It has great documentation. I mean, probably if you're just trying to do good backends, you can go with Nest. There's almost no way you can do it bad. And it's solution for middle to big organizations. I remember we had framework over Nest. It was super easy to use, so we had like observability out of the hood. Some observability in for GraphQL, which is more tough. Again, out of the hood. Optimizations and stuff like this. So just platform team created it. And what's next? Data format. We can use whatever we need. It's not limited by protocol. We can use JSON. We can use XML. JSON is the most used. We can play with optimization. If performance is key for us, we can, use some ways to make it less. And documentation. Everybody wants to have some documentation for their service. So I believe that's what you would see if you need to integrate with API. And yeah, it's done automatically for Fastify and Nest. I remember we were trying to create it for Koa, and was a bit tough because Koa is, it's not natively for TypeScript, and we had to play around it. Observability. It appears that observability is more or less done for a lot of backend services, a lot of REST APIs. It's done out of the hood and just need it. I'm telling about observability because it would be, let's say, more difficult to do it with GraphQL. I'll cover it later. But yeah, caching. One of the good points from HTTP protocol is caching. Like, I believe 80% and more is good hash rate. It's implemented most likely by browser. Maybe your own system kind of behind browser. It's not always browser, but a lot of requests are cached. It's super easy to do it. Yeah, and it was good about REST API. So what's next? Then was GraphQL API. It was developed by Facebook. And the problem with REST API is that when you have endpoint, you can just do something. But when you need to change something, you have two options: either create new endpoint, either create, I don't know, modify existing. Yet modifying existing will have some drawbacks, like just loading much more data than needed. Creating new one, it's work from engineering team. No one likes it. So Facebook introduced GraphQL. The idea of GraphQL is simple. Okay, it's used by almost 30%, so it's growing. And the idea is simple. So we have query, just front end ask whatever he needs. And we have types. Types are important here, because when we work with JavaScript, well, we need something to be more or less type safe. We don't want all of those null pointer exceptions, whatever. We need type safety. And GraphQL can just help us with types. It will generate something from these types. I believe it will cover it. But the point is that we can just fetch enough. So imagine we have some field that is kind of expensive to fetch. I don't know, it may be consuming a lot of time, or it may be just, I don't know, we may just pay for it. It may be open API. And it's not always needed. Let's say we need for payment this expensive field, but we don't need it for home page. So if we were to do it in REST, we would create new endpoints. With GraphQL, you can just define schema, and client would just ask for it if it's needed, and otherwise we won't serve it. So, and the nice thing is that we can use modern framework to just execute expensive field kind of when needed. So it's super easy and super integrated in the ecosystem. Code generation. It's another nice thing. Most likely, if you use GraphQL, you'll have something more or less consistent across server and client, and you can just play with those schemas. So this, let's say this is whatever your GraphQL query, GraphQL file, and it will generate code for you. You'll just share it with your teams. Yeah, it's supported by major frameworks like Apollo GraphQL and Nest.js, which uses Apollo GraphQL under the hood and just, I don't know, add some magic sauce. Documentation. It also supports documentation, and I believe it's just created automatically. So you have schema, and there's a definite way to create documentation, so it's just solve it. And it's super easy to use. You can just search this tool, and I was integrating with some other services. It was so nice to have this tool to search it and to know exactly what I need to use. And yeah, but the problem, caching and observability. Let's say with caching, it should be done on client side. You don't always know what exactly to cache. GraphQL is served on the /GraphQL endpoint, so there is no automated way how to do it. So like you will need to come up with something. Observability is the same. I believe even with SLOs. So if for REST, you can say, okay, you just need to serve 99% of requests with, I don't know, 5 minutes. You can say it. With GraphQL, well, it can be tricky. So error handling. When REST API just returns your status code, everybody knows what is status code and how to use it. GraphQL would return you everybody is 200. Everything is okay, but we will have error. We will have error codes, and we will kind of be connected to this error code. This, again, may create some issues for us. What's nice feature about GraphQL is federation. So imagine we need to create, for our homepage, we need to get our user and get services and get orders, get his products, get the user itself. We need it for our homepage. We will make, I don't know, if we do it straight, we'll make 3 different requests. First of all, we will lose a lot of time just for network, just for communication. We will pay for it, it's money. And it's time, we don't want. So what GraphQL introduced? It introduced federation. Federation is just merge a schema. It just kind of know everything about all of those services, and we would call federation. Client would call federation. Federation will just serve those requests. It will collect information, and then it will return. The client will be happy. It will be faster. It will be cheaper. And it's, yeah, well, that's how it looks. It's super easy to use. So and with this framework, it's Nest.js code, so just some decorator, some function, it works. And yeah, just super recommend if you use GraphQL, try to play with federation. And the next thing about protocol APIs, protocols is gRPC. So for first two was mainly used for clients, and you can imagine that you have a client, just you speak with it. I believe performance was not really a bottleneck. But when we have microservices, we want to speak fast. We don't want to spend a lot of time on a lot of even money on networking. So we want smaller bodies. We don't usually need those headers. You can play with it. And yeah, that's why gRPC was introduced mostly. It was done by Google. And what? Okay. Yeah, nice thing. It requires HTTP2 protocol. How many of you knows what HTTP protocol do you use? So, well, for me, it was a bit of interesting knowledge that there are different protocols, and behind them usually was a big company. Behind HTTP2 protocol was Google, and it was more or less implemented for our own needs. Then it was, let's say, open sourced, and Google worked with a committee to make it standard. So gRPC is our HTTP2 protocol. It may be tough. I Googled and I see that in Node.js, it's still for some reason maybe tough to use HTTP2. So you just need to play with it. So we use protobuf for all of this stuff for performance reasons. We don't like JSONs. JSONs are big. JSONs, when you use JSON, you send key. Key is a string. It's memory, isn't value. And you can kind of play with it. You can archive it, compress it, yet we can introduce some schemas. And schemas are good. gRPC is good for strongly typed languages. It's related mostly to the schema. And it's good for streaming. I believe, again, it's related to the point that we can use WebSockets. We can stream via WebSockets, but it's expensive. If we have cheaper way, we can do it with gRPC. So protobuf. Protobuf is a schema that's often used behind gRPC. It's smaller than JSON. And yeah, it looks kind of like this. The good thing is that it's backward compatible more or less by design. So if you're working with REST API, you can, I don't know, you can introduce break and change if you do it blindly. I believe with protobuf, it's a bit more tough. You will always use kind of reserved word, and somebody will easily notice it. It's, yeah, nice thing. Another nice thing for the stuff. I remember we used it in message brokers. So we need for message to be small. We kind of usually we store this messages kind of forever. So we need it to be small. We need it to be type safe. We need it to be kind of system should exactly know what is in the message. So it's used for code generation. It's a nice thing that we can define service. We can reuse it, and we'll use it for some languages like Java. Let's say there are types are necessary, and I see it used a lot with Java, with strongly typed languages. It can be easy with JavaScript to play, I don't know, say whatever is JSON, parse it. If it's Java, it's tough. So let's go briefly over examples. REST API is used in Stripe API. It appears to be golden standard. GraphQL API, it's, I would say, more flexible something. You can just play with it. PayPal use it. And here's nice contrast. So Stripe API uses REST. GraphQL API, PayPal uses GraphQL API. So it's like never an obvious choice. And it's used for Studio API from Netflix, again, for this just ideas that we can query whatever we need. And gRPC, it's mostly backend to backend communication. So it's used in Netflix. And yeah, I see a lot of RPCs in Web3. So I believe almost each request is gRPC. And I believe that's it. So let's connect. And I'm open to questions.
Yeah, thanks for a great talk. Very nice, compact combination of the most popular ones. I'll ask two questions. Like, first one is more about your experience, like which protocol do you mostly use? And also, did you have an experience with tRPC?
I don't really had experience with tRPC, probably. Well, my first experience is mostly with REST. At Google, it's mostly RPCs when you speak backend to backend. There's also a bit of GraphQL or some kind of GraphQL, but we mostly use RPCs.
Okay, thank you.
All right, one more question over there.
I have a question about GraphQL. Like, what do you think? Because I think it had its glory days like a couple of years ago when people were excited about GraphQL and types. But now I see in projects that people are actually using REST endpoints to serve schema for their objects, which seems like great fit for GraphQL. But for some reason, people like don't like it. Do you also see that and have some thoughts on that? Why that may be?
So if I see that people don't use GraphQL, it's kind of decreasing usage. Was it the question? Or
No, the question was, what do you think is the reason that people don't like it? Or do you think that,
well, GraphQL is a bit complex from my view. I remember my friend was telling that, so a query is simple. When we query GraphQL, it's simple, we just know the answer. But with mutation, it's a bit tough. Let's say when you want to change some resource, and then you want to, I don't know, get some resources, maybe some resources will be related. And then there's a big chance that you will have race condition. So you'll query another system, federation will query it for you. And UI will see kind of a bit of outdated information. I believe it's also like with every technology, when it starts, there's some peak. And then people will be just more mindful when using it. So maybe it was a peak and now we just see that, I don't know whether it's really needed or not. But yet I saw some surveys and they say that people kind of use it. I believe it was 24% or something like this in 2022. It was 29% in 2023. So it's a slowly increasing usage.
thanks?
Like types and the client generation for like backend queries, especially in Google with like, I don't know, to also work in monorepo project where everyone does everything, or it's a bit less like spread.
Well, it's internal tools at Google. I believe our tools are usually known by different names in public and internally. So, yeah.
Okay, classified information.
Certainly classified. I think Google has like mega repo, not even like monorepo. It's like giga repo.
That's true. That's true.
Okay. Well, a round of applause for our esteemed speaker, please.
Warsaw.